This right here is a segmented turning. We normally think of a segmented turning as a bowl, but this right here, by definition, is a segmented turning. Cindy Drozda, yeah. She came and taught us how to do these little finials, but you have to practice. Okay. So it's any turning that incorporates numerous pieces of wood in its design. Segmented turnings includes those where the entire segment, where the entire piece is made of segments. For example, here's a segmented bowl. Everything is segments. The base, all the rings, the rim, everything is made up of segments. This one is, each ring is a 1/2 inch thick, and there are 16 segments that are tapered, and then 16 straight segments. So there's 32 pieces per ring. So 1, 2, 3, 4, 5, 6, 7, 8 times 32, and then 16 on the bottom, a bunch. So that can be a segmented turning, or it can be something where only a portion of the piece is a segmented turning. Now this is a piece of sapele that my friend Wayne Hancock gave me. It was about 1 inch thick, 10 by 10, something like that. And I thought, well, sapele is an interesting wood. It's got chatoyance, that glimmer, that shimmer. That's a French word. It stands for the eye of the cat. So it's got chatoyance, but it's sort of a plain wood. So if I had made something out of this, just the sapele, it would have been kind of plain. So what I did is I just added 1 ring on the top with some paduk or however you pronounce it, as the straight segments, and then some more sapele as the tapered segments. So just by adding 1 ring, you can take something that's fairly simple and kind of liven it up. That looks good, don't you think? Yeah. Great, yeah. And also put a little piece on the bottom, kind of give it a little bit of a platform. So, yeah, that's the definition. And of course, a segmented piece can be several thousand pieces. And I don't think I'm going to venture into that field, but if you want to, I'd love to see how you do it and tell us all about it. Or it can be just a few. Now, before I get started and all of this stuff up here, I want to address 3 questions that you may have. What, how, and why. Okay, I've already touched on a little bit about the what segmented turning is. It's basically any numerous pieces glued together and you turn it, and that's a segmented turning. And then the how, we're going to get into, I've got this board up here. A few years back, I don't know if some of you remember it, but I found this poster when I was digging around my stuff. This is what I did about 3 years ago on the segmented piece. And it was a little bit confusing for some folks. I believe this is the result of the planning. That one right there. This is Peruvian walnut and spalted pecan. But anyway, so we're going to look at how, and what I'm going to do is this bowl right here. We're going to make this bowl, so to speak, right up here. I'm going to show you step by step how you can do this, okay? Now, the thing about segmented turning is that it takes time, and it requires patience. You have to be organized. Pardon? I'm out. Have to be organized. Sometimes it can be a little bit tedious, and it demands absolute perfection. and accuracy. So you're probably wondering, well, why in the world would anybody want to do a segmented piece? Segmenting turning does have some advantages. Now, usually, well, not usually, always, you begin with dimensioned lumber. And from there, you take your dimensioned lumber and you slice it up into various widths on your table saw, and invariably you're going to end up with little scrap pieces of wood like these right here, you know. So what do you do with that? Well, you don't throw it away. What you can do is you can save them, and when you get enough, you glue them together. This was a 10 by 10 that I glued up out of scraps. And I've never turned a square platter. This is my first, and I thought it turned out pretty good. What do you think? So that's, thank you. So that's one thing that you can do with the leftover bits. Also, this right here was a 13 by 13, 3/4 of an inch thick, and I cut consecutive rings at a 45-degree angle, and I produced this. And my second piece that I'm going to spend a little more time with involves this very guy right here. So you know, you take all these pieces and stack them up and glue them together, and this will look very similar to that other one over there, I hope. So, segmented turning is efficient. You don't waste very much wood. In fact, you waste very little wood. You might say, well, yeah, but what do you do with the little blocks like this, you know? Well, we've been talking about boxes. They make beautiful little boxes. You just glue them together and voila. See? And but then you say, what's next? You say, yeah, here we go. But what about these little scrap pieces like this? What do you do with that? You just throw them away, right? No. Where'd it go? Ta-da! Oh, there they are. I bought a pressure pot from Harbor Freight, so I've been playing around with some epoxy. So that's what you can use those little square bits for. They make wonderful pieces. This is my first one, and this is my second one. You may recognize this shape, this Tupperware. But let me advise you, before you go raiding your kitchen, make sure you get a good release agent, or else it's a one-time deal. So anyway, I found this fella on YouTube, and he has found, according to him, the perfect release agent. I'll just pass this on. It's a 50-50 mix of petroleum jelly and odorless mineral spirit. It has to be the odorless kind. And you mix it up and you paint it onto your mold, and then it'll release a lot easier. But I found something better than that. You go to Dollar General and you buy an acrylic bowl for $1, and that's what I use to pour this. And so, anyway, now.
Is the bowl still on it?
No, turned it away. Yeah, I turned it away. Also, there's one more piece. You remember the round bits over there? It was originally 12 inches square. Well, when you cut the big circle, 12-inch circle, you got those corners, right? You just throw them away, right? No. This pin came from the two corners on one side, and this pin came from the two corners on the other side. So you see, when you're doing segmented work, it's very efficient. You hardly throw away any of the wood, which is important, because some of these exotic woods that you use, they sell it by the inch, so you want to make sure you use every inch, you know. Okay, so um, the definition. Why? Okay. Another advantage to segmented work is the availability. Now, if you can get access to solid pieces of wood like this, then that's great, that's wonderful. But you know, when you're dealing with solid work, if it's green, then you've got to rough it out and you've got to wait for it to dry and you got to hope it doesn't crack. And if you just let it lay for a few years, then you got to deal with the wormholes and the rot and all this sort of stuff. But with dimensioned lumber, it's available just about anywhere. There are lots of places where you can get lumber, and lumber is useful. It's used in the making of the segmented pieces. For example, let's say you wanted to make something like this out of Purple Heart. That's a big chunk of Purple Heart, isn't it? But with using the principles of segmented turning, you could build this very easily. Now with most turnings, like solid stock, spindle turnings, basically anything, you start with a piece of wood and then you start removing what you don't want until you get to the finished product. But with segmented, it's a bit different. You start with an idea and you build on that idea, okay? So, yeah, here's another thing. Segmented turning is very flexible. You can change horses midstream, so to speak. This is going to be my demo today. We're going to build this thing right up here on this poster. And what I had in my mind is I wanted a bowl that showed something that looked like brickwork. So that's why I went with this. And I had a little bit of wood left over, the catalogs. This is Mexican ebony here on the bottom. So I was making another one out of some plywood. See, you can make a bowl out of plywood. I was making this one out of plywood, plywood. And I was doing the same thing, same basic shape. I used the same pattern. But on the rim, when I cut my 12 tapered segments, and then I cut my 12 straight segments, I only had 11. You need 12. So what do you do? Well, I looked around my shop and I found some wood that would complement the catalogs. And I don't know what it is. It just came in a grab bag. I don't know if you can see that. Ah, there we go. It came in a grab bag, so I don't know what it is, but I had enough to make these 12 straight segments and plugged it right in there. After I finished it, I got to where thinking that, well, I prefer that. So another thing that I've learned from these guys here at Magnolia Wood Turners is that you never have a mistake. You never have a boo-boo. No, you don't. They call it a design opportunity. Right, it's a design opportunity. And I've used lots of design opportunities. Okay, so, boom. Available, it's flexible. The lumber that you work with is dimensioned lumber. I get a lot of it from places like Woodcraft and Packard, these online places. But I watch for the sales, because every now and then they'll sell their exotic lumber, sometimes half price. Back before Christmas, Woodcraft was selling Paduke. What was it? Paduke, Canary wood, Osage orange, some various things like that for half price. So, I'll order a little bit and I'll store it away. And several years back, I got some Peruvian walnut, and it came in a pack of random widths and lengths. And I've used that for years. I've almost run out because you see, you don't always have to use the same wood to do a segmented piece. You can incorporate some other pieces. There are some products you buy and you look at the ingredients and it says active ingredient 2%, and what's the rest? It's a filler or something like that, right? Well, you can make a segmented piece and, like, say, use Bacati, which is a very expensive, beautiful wood, but you can incorporate a lesser expensive wood in with that, like, making a geometric design, a pattern or whatever, and it'll kind of, bring the cost down a little bit, but it'll also make it more interesting. There's a lot of things you can do, even if you make, well, let's see, I made a platter just like this out of the Peruvian walnut, and it was all Peruvian walnut. And what I did is I had the tapered segments, and then the straight segments was the end grain. Do you know what happens when you put a finish on side grain and then put a finish on end grain? It changes the color. The end grain will usually darken. Well, I made the whole platter out of Peruvian walnut, which is this very dark brown walnut, the color here, that wood right there. And so by mixing it up, by having, this end grain segment and then a tapered grain, when you put the finish on it, it made it pop, and there were lots of different interesting shapes there. This one is all segments. I call it my heart platter, because this is yellow heart, that's purple heart, and that's red heart. See? So you can kind of mix it all up. Now, oh yeah, I wanted to spend just a couple of minutes on where I got started. Before I joined Magnolia Woodturners, I started playing around a little bit. You remember I said that for me, wood was firewood, lumber, or plywood. Well, I didn't know how to turn firewood. I didn't think you could turn plywood, so that left lumber. This is a 2x6, two of them glued together. And actually, it's kind of interesting. That's not bad for pine, is it? So that's two pieces of pine glued together, and the base is fir, a 1x4. So that, I used what was available. And look at that. That's real professional, isn't it? A wood screw holding the base on. But, that's all I knew. I mean, when you know very little, you only have one way to go, right? And that's up. So, but anyway, I started playing around with that, and then I had some more lumber. I found some oak, and it was 8-inch, 2x8 oak, and it was rough sawn, and that was the actual dimension. So I made lots of bowls out of this 2x8 oak, and I tried different shapes and everything. And then I got to thinking, I'd like to make something a little bit larger, but I was limited to that 8-inch diameter, because you can't make a 10-inch bowl out of an 8-inch piece, right? So then my daughter gave me some king wood for a Christmas present, and then I thought about gluing it onto the end. So rather than cut the corners off, I was able to just, increase the diameter. So this was the beginning of my segmented turning. Okay, now, another thing about segmented turning is that it's almost endless as what you can do. I mean, you're basically limited by your imagination and maybe the size of your lathe. But there's a lot you can do. So after, having covered all these basics here, what I would like to do is show you what I did up here when I made this bowl. Okay. Now, this was the actual piece that I worked with. And what you do is you only have to concern yourself with the center line out. I've seen some teaching done like on YouTube where they'll draw a cross section of the entire bowl, but that's not necessary. You really only have to concern yourself with the center line out, because think about it. When you got your gouge and you're on your lathe and the wood is turning and you're removing that wood with your gouge, right? You're only taking it off on this side, on one side. It's like magic. It disappears on the other side, right? So you only have to just work with. And also this goes to show you, you don't have to have something this big. The only reason I've got this is that I wanted to make it easier for the people in the back to see. And I hope you can see this back there, right? Yeah. Okay, so, but this was my actual piece. So you remember I said that with segmented turning, you first start with an idea, and then you build on that idea. So what I did is I had this idea in my mind that I wanted to make a bowl about 12 inches diameter and about so high, 5 inches, 4.5 or something like that. I had some catalogs. That was a 1x6, about so long, and I thought, well, that'll be enough. So I made the base, and then I'd have enough left over for the rim. And I had seen these brickwork patterns before, so I thought I wanted to do that. So that's what I did. And I chose for my layers to be 3/4 of an inch thick. And so what I did is I got some maple, and then this is some sapele that's been glued on. Now the maple, I planed it to, it was 3/4 inch stock, so I planed it to 5/8. And then I resawed some sapele, and I planed one side and glued it to the maple. And after it dried, then I ran it back through my planer to get the dimension of 3/4 of an inch. So that's my plan. All of these are 3/4 of an inch. And so this is this is the ring number 1, right down here. It came from this, and then of course ring number 2, and then ring number 3. So let's get started. Now, remember, you have this idea. So I'm thinking to myself, well, what I'd like to do is I would like to make a bowl that looks something like this. So you're going to get your paper, your cardboard. I have used just scrap pieces of plywood, just lay it out. Do your center line, do your baseline, and whatever diameter you're going to work with, okay? In this case, it's a 12-inch bowl, so this is going to be a 6-inch radius, So within these parameters right here, the center line, the base, and the top, I sketch in a shape. This is what I want my piece to look like. Now see, if you were turning a solid piece, you'd have to have a big piece, and you start turning it and you work towards that. But with segmenting, you start with this idea. This is my idea. This is what I wanted to do. So I started with that. Now, this poster over here gives you some couple of little simple formulas and some terminology that I'll be using. For example, this is your tapered segment, all right? And for a 12 segment piece, you got 360 divided by 12. it's 30-degree angle. This right here is a 30-degree angle. If you were to extend that down. And since you got 12 of them, 12 times 30 is 360, you know. So if you got 16, then that's going to change, or 20, that's going to change. So the length of your segment is L, and the width of your segment is W. And we're going to be looking at where L and W come from when we do this up here. And of course, now when you deal with the length, you've got to include or compensate for that straight segment. For example, the straight segment is going to be this vertical right here. These are the straight segments, all the verticals. Now, also when I was doing this, I wanted all of it to be side grain, yeah. See, another nice thing about a segmented bowl is as you turn it, it's always side grain, side grain, side grain. There's no end grain there, unless you want the end grain to be in there. So what I had to do, obviously the horizontal pieces, the side grain's no problem, but the the vertical straight segments, they also had to be end grain. So I had to cut the board in such a way that that would be produced there. Okay, so, all right. So there's our basic shape. And you know, what you can do is you would pencil it in. You say, okay, I like this, or I don't like this, or whatever. So that's the basic shape. Now, let's see. Where's my stuff? Now what we're going to do is we're going to cover up that shape. My wife was a school teacher, so I've got lots of this stuff I can borrow from her. Okay. So this piece right here, this represents the base. Remember the base, it was a 1x6, and what's the radius of 6 inches? 5 inches, I'm sorry, 5 inches. It's 2.5 inches. So I know that I'm going to have this, right? And then, what is what stuff?
Your wife had plenty of it. What is it?
Oh,
Poster, tag clay or something.
yeah, it's the sticky stuff.
It's good for sticking stuff on the wall.
Yeah, that's it. Sticking stuff on the wall.
It's new. No, it's old.
It's been around. And, oh. Yeah, that's right. It's reusable. Okay, so now for my first ring, see, this is going to be the thickness of my catalogs. So for my first ring, what I want to do is on the inside, I want to go past my line, and on the outside, I want to go past my line. How far? I usually go 1/8 of an inch on your drawing. Okay, so we draw a line here, draw a line there. So our first ring is going to look something like that, right? Now, for the second ring, and see, we haven't done any math yet, have we? No math. No math.
Do you do this on every one of your pieces, Jim?
Yeah.
You draw this like
Yeah,
that,
right.
you can get a-
Right, I sketch it out, and I just go in there and I make little check marks. Okay, so on my second ring, I want to come past the line here on the outside about 1/8 of an inch, and I want to make sure I'm on the inside about 1/8 of an inch, roughly. It doesn't have to be exact. So my second ring is going to look like that. Now these rings are going to be glued together, right?
Jim, you've been talking about the wood. Do you have to make sure you've got the same moisture content and everything that you glue together?
You know, I haven't had to deal with that. To me, it's dry wood, and it's in my shop. I do have a metal shed where I keep some stuff stored. So if I'm going to be doing some turning and I want some lumber, I will bring it in my shop, which is climate controlled, a little while, you know, kind of let it, what do they call it, equalize, acclimate. Yeah, acclimate. So anyway, this is what a ring would look like when you glue it all together. As a matter of fact, this was supposed to be ring number 1. And in my haste, remember, did I mention you have to keep focused on what you're doing? In my haste, I glued it all up. I was so excited, everything's going so well. I forgot something. What did I forget? The straight segments. They're supposed to go between there. Yeah. I thought, oh well. But that's all right. It'll come in handy for something later on. So anyway, now we're ready for ring number 3. So ring number 3, we're going to come up here outside this line here, come out, and then on the inside go past that line just a little bit. And I've already got my maple and the sapele. They're glued and it's plane to the right dimension. Okay, so this is the base, ring 1, ring 2, ring 3. All right. We're ready for ring 4. Now ring 4 is going to be a little different. Ring 4 is going to have the, what do you call it? The mortar. You know, this is brickwork. The mortar is going to be on the top and the bottom. So this ring right here is not 3/4. It's going to be 7/8. See, this is 3/4, 3/4, 3/4. This one's 7/8. Why do I have this here? It's because the top ring is going to be just plain catalogs, right? This is the rim. And you can do lots of things with the rim. I really like a dark rim on my pieces. Wangi is a good wood to use for that. Okay. So we had our shape, put it in there, and now we've decided, okay, this is what we've got to have. Now these are rings. All of these are rings. This is a solid piece. This, you know, okay. Now, this is where the math comes in. Anybody got a calculator? Okay, all right then. I think we're going to go above 20, so. Okay, so on our design right here, on our drawing, we come out here, and this ring, this is the outside diameter of our ring, and this is going to be the inside diameter of our ring, right? It's like, yeah, I showed you that example, yeah. Outside diameter and the inside diameter. Okay, so the outside diameter, you measure out the radius, and the radius comes to 4.33 inches. Or what's the diameter if the radius is 4.33? 8.66. So I want to know what's the circumference of this ring. So how do I figure out circumference? Pi times the diameter. Oh, I forgot to tell you what pi is. 3.14. There you go. That'll work. 3.1414 times the diameter, which is 8.66.
27.2.
Okay, that's the circumference. But now we've got 12 segments here, right?
Okay.
So we want to divide the circumference times how many segments we're using. If you're using 16 segments, then you got to divide by 16. So what's that number divided by 12?
2.267.
Okay, so the length L is going to be 2.2, let's just do 2 decimal places. Okay, 2.27. This is L. But now we're going to have an 1/8 inch piece of sapalian there, right? So what we have to do is subtract the 1/8 inch from that L when we cut the maple. Is everybody following? Okay. What? Pardon?
What is an 8? 1.2?
An eighth, an eighth is 0.125. 0.125.
As we develop dementia, how do you compensate for that and all that experience?
Okay. All right. So, well, for now, we're just going to deal with just the length. Okay. So, but now, what is the width? Okay. If this is the outside diameter and the length of our segment, if we got 12 segments that are 2.27 inches long, and the angle is correct, you put them together, you're going to have a circle that is 8.66 diameter. But now we need to know what the inside is, because it's not necessary to have all of this wood out here, is it? Because if all of this is wood, you just have to turn it away. So save yourself that wood. So what we do is we measure from here to here, and that dimension is, I've already measured it, is 2.63 inches from here to here. So you get your lumber, go to your table saw, you set the width for 2.33, and you rip you a piece 2.33 inches wide, 2.63 inches wide. And then you start cutting it into segments. Now let me pause here and talk a little bit about cutting your segments. When I first started doing these segmented pieces, I was using a miter saw, and it was pretty accurate, but it wasn't real accurate. So what I had to do, because the saw wasn't exactly a straight, nice, smooth cut, and it wasn't a perfect 15-degree angle, what I would do is I'd take those segments and go to a disc sander, 12-inch disc sander, and I had the miter gauge clamped to the table, and I tweaked it in as closely as I could, 15-degree angle. So then I would take those pieces and I would push them against the sandpaper and flip it over and do the same thing. It worked fairly well, but I learned that I have 3 variables that I'm trying to deal with here. So you throw in 3 variables in the mix, and there's all kinds of possibilities for error cropping up because, for example, the miter saw, it wasn't real accurate. And when it comes to the disc sander, how hard you push and how long you hold it there, you see, it has an effect. So as hard as I tried to be consistent from one piece to the next, you still have that variable there. So what I did is I made myself a sled for the table saw. And this is about as cheap as you can get. I mean, it's a scrap piece of plywood. Well, it's all plywood. And this is a piece of maple that runs through the miter gauge on your table saw. Oh yeah, it goes this way. And what I did is I scribed a 15-degree angle with a pencil, and I took a couple of wood screws. I fastened it down. And then I got some scrap plywood, and I cut them into 1.5-inch widths, and then I made 12 segments, about so long. Taking those 12 segments and a hose clamp, I clamped them together. And then I held it up to the light, and I looked for any little cracks of light coming between. And guess what? I found some. So what I did is I pulled that screw out, and I tried another hole, and another hole, and another hole, and another hole. But I finally got to exactly 12 inches. 15 degrees, thank you, for those 12 segments. See, I'm not accustomed to doing this. But anyway. So this is what I used to make this bowl. So if you got some scraps and got a little bit of time and a hose clamp, then there you go. So now this is, of course, the only bad thing about this particular sled is that it only cuts one angle, 15-degree angle. What if you want to do something different? Well, okay. Let's see. Now this is a different sled. I made this sled because I thought 2 tables were going to be enough. Maybe I'm just not organized. Huh? But I bought these little triangles. And they come from a company called Seg Easy. I've got a handout that I'll be passing around once we're over with, and it'll have the names and addresses and websites of these various companies that I'm mentioning. This is Seg Easy. This is a 16-degree wedge. A 16-segment wedge, a 24-segment wedge, and a 20-segment wedge. I didn't buy a 12 because I already had a 12, you know. So, but the nice thing about using the wedges is that you can play around with these angles here, rather than having a balanced angle. You could have offset angles. Let me show you. You know, picture's worth 1,000 words. So you can play around with different angles, you know, just so long as the two together are supposed to be what they're supposed to be. And so I made this one. There's no glue. It's just held together by this hose clamp. But by using these wedgies, you can play around with different angles. You know, you could have one ring that looks like this, and the next one, you flip it around, and, you know, just let your imagination go. So there's that type of segment cutting ability. And then when we were in Waco, we bought this guy right here. This is fancy, fancy, fancy. This is also, I've got this information for you in the sheet. Pete Markin. And he did it on the CNC. He can do, with this, 10, 12, 16, 20, 24, 36, or 48 segments. Just by loosening these thumb screws, pulling this pin out, rotating around, and then pushing the index pin back in place. And it's pretty accurate. Let me caution you about 48 segments. or need I bother? That's a lot of segments that you're going to put glue on. And when you start with segment number 1, by the time you get around to segment number 48, and what if you're putting straight segments in between there? Then you're going up to what, 96 pieces for a ring. Be careful that your glue that you start with hasn't already dried before you make it all the way around. So anyway, so there's that. Okay, now where were we? So you're cutting your segments. You glued them together. Oh yeah, we've got ring number one. Our segment's going to be 2.27 inches, and that's the total length. So whatever your straight segment is, you got to subtract it. Okay, for ring number two, we come up here, and we see that the radius is 5.5 inches. Well, that's easy. What's the diameter? 11. So what's 11 times pi? Okay, and divide that by 12. Okay, so the length of our segments for this ring right here, that L dimension is going to be 2.88 inches. So from here to there, you get your little scale and you measure it, and it works out to be 2 9/16. Okay, now we're ready for. Now, actually, this is easy. Look at this. We're right out here on the 6-inch radius, 12-inch diameter. So once we calculate what this one and this, they're all the same, all right? So the radius on this one is 6 inches. The diameter is 12 inches. So what is the length? 1. No. It's pi, yeah, exactly. It's pi. So the length of our segments here is going to be 3.14. We measure this length right here on our drawing, and it works out to be 1 7/16. Right? And then this one up here, the length is going to be 3.14. But this is a little bit shorter, and so the width is 1 inch. And then for this ring up here, which is our rim, 3.14 is the length of that is the included length of the segment, and then the width is 1 inch. So there's your material list. So you can just go to your table saw and start cutting. What I like to do is cut the wide pieces first and then start working your way down, because what if you got, what if all your stock is 3 inch or 4 inches or something like that, and you start cutting all the little pieces, and then when you get down to your big piece, you realize, oh, gee, I need 2.2, I need 2.63, and it's only 2.5. So you start with your big pieces, cut them first, and then work your way up. Okay, so these are your rings. So you're going to have your base, which is a solid piece. And then you're going to have these rings looking similar to that one I showed you back over here. Like this. This would be for this ring here. Now what you have to do is, of course, you do a dry fit. Put them all together. Put your hose clamp on it. Check it for light. Okay, it looks good. Then you come back and you use I use the Type Bond 3, which is the extended working time. It's in the green bottle, okay? And then you glue all your pieces together, and what you have to do, though, you've got to make sure that the surface on the top and the bottom of each of these rings is fairly flat, because if if you've got cracks and things like that, it's not gonna fit together. So you need to sand those down, and then it's just a case of gluing all these rings together. Now, have you ever tried gluing something and you take your clamp, and when you clamp down on it, it goes, I hate that. So what I do is I found some steel weights, and I just put them on there, and I just stack those weights on top, and you can kind of you stand over it, and you kind of wiggle it and eyeball it and make sure that everything is right where it needs to be, and then just leave it, and it'll set up. Okay, so after it glues together,
Yeah, I'm a little bit slower than everybody else, but your L is the outside of the bowl, right?
yes, the L is the outside of the bowl.
I think about that every time I look at it. That's the outside circumference.
Yeah,
That's the most confusing thing apart about this is which way does this segment set on the exterior of the bowl?
yeah, right.
Well, do you always make the segments almost all the way to the center? I mean, you're gonna cut all that out when you start turning, right?
So that's what he's doing right now.
Yeah,
But I mean, you got that thing with like a 2-inch drill hole in it. Could you make it where it's just a rim and you have a big hole and glue the segments together? In other words, cut that out on a bandsaw with a drill press or whatever.
Yeah, but,
Depending on what you wet is.
it's got the curve there. And
That's
it's
the
trying
bottom
to
ring.
extend that,
The top ring is gonna be.
it extends from the beginning,
The bottom curve is almost flat, Tommy, so it has to be wider.
yeah,
So that's the bottom.
this is the first ring.
Okay.
first ring.
The first ring is going to sit in there like that.
But as you go up to the top towards the rim, you can make them, the
Yeah,
rims smaller.
right, exactly. See, this is that first ring.
Yeah,
So in order for it to
I got you.
go this far, it had to be this wide. You see, that's the difference between the width and the length.
Yeah, I think if you did one, you could up it
Okay, I'll do this. Yeah.
Do you generally go straight from bandsaw cut to glue up, or do you have to do any more finish work on the edges to get a good solid glue on it?
No, that's
You go straight from table saw cut?
yeah. Mm-hmm.
So you use a special blade, I'm sure.
Or on my table saw?
Yeah.
Yeah. It's a
Thin
a
blade,
Freud. Okay,
rod.
it's a fraud, yeah. Okay, then you take your blank, you go to your lathe, and you start turning. And let's see. This is going to be, whoops, my stickum didn't stick.
And we don't do that, I was about to explain to you.
Okay, so this is going to be the finished shape. Now, let's see. There is a slight difference between these two, and that's because you have a little bit of flexibility. So, you can make an angle a little sharper or a little less than you see. But anyway, that's it. That's all there is to it.
Did you make the design, let me get this straight. You made the designs change. Did you change those segments?
No,
Or did you
no.
change this after you included?
You have enough material in there that you can
Okay.
tweak it a
That's
little
what I
bit.
thought you meant.
I mean, you couldn't take this and suddenly go out.
You can make it steeper, but not, you
Yeah.
can't bring it out.
Right, you can see there's a slight difference there. So, you got a little bit of flexibility.
Is your wall thickness, between those two, does it change, the wall thickness change?
They're about the same. About the same, yeah. could.
It might be nice to have.
If that meant the same old way, at that point, it's just like,
Well, for mounting it on the lathe, I like doing the, what do you call the inside bore?
Expansion mode.
Yeah, the expansion mode. Yeah, the mortise. It's the mortise expansion mode. It's a female tenon. Okay. But that's what I like to do, and
I kinda like the transgender tenant.
I tried making one of those and it just didn't work. So, but anyhow,
I don't even want to.
if chatter is an indication of how if you're enjoying yourself, I think you must be having a lot of fun because a lot of chatter in it. Anyway, I'm glad we had the opportunity to have a little quick break because there's something I had talked about, and I wanted to, give you an example. You remember I mentioned that side grain and end grain will absorb your stain or your oil or whatever. Well, see, this right here is all poplar.
Can we hold it down so we can hear it?
This is all poplar, but you see the different colors in there. Came from the same board, but it's oh yeah. There we go.
What then?
This is side grain, end grain, side grain, end grain, side grain, end grain.
Danish oil,
Danish oil, yeah.
that was the same board?
Same board. Now, obviously, there was some pieces of the board where the poplar, poplar has streaks.
Yeah, poplar could be.
I don't know. It just said poplar. But it had streaks of olive green and cream and black. But right in here, this is the difference between side grain and end grain. Okay, now, we've got a lot of ground to cover, and we only have, when do we leave here, at 6? No, okay. Now, the second little demo I'd like to do is talk about something like this. This was a 13 by 13 glue up that was 3/4 of an inch thick. All right, and then I cut concentric circles and glued them up. Now,
What kind of circle?
concentric?
Have the same center.
Okay, so as you can see, this was a 12 by 12. You remember the pins? One pin came from over here, one pin came from over there. So this is what it looks like. And
Okay.
yeah, it's a 45-degree angle. I'm going to make a mess. Okay.
You want somebody to hold?
Actually, there are three ways that you can do this. Okay, one way, and this is the way I did it, and this is the way I prefer doing it, is I drilled 1/8-inch holes. And I used the scroll saw, right. And see, with an 1/8-inch hole, you can feed the scroll blade in there. You may have to grind a little bit of the pin off, feed it in there, tilt your table at a 45-degree angle, and just get comfortable because it takes a while. A little scroll saw. And even though the thickness of the wood is 3/4 of an inch, when you go in at an angle, you're increasing the length of cut by maybe an inch. Now, a scroll saw, it's a little teeny-weeny blade. If you give it too much pressure, you're going to snap it, right? So I found a little technique that helped. I'm sure most of you have used a chainsaw, and when you cut through a log, you don't go straight down, do you? What do you do with that chainsaw? You rock it. Why do you rock it? because it cuts faster and easier, and there's less contact, right? Okay.
More new wood.
Yeah, right. So when I've got this up on my scroll saw, how is it? Oh yeah, it's like that. I feed the blade through there, and what I do is you have to make sure that the center of your object is still pretty straight up with that blade, but you just gently rock it back and forth and go all the way around. Now the first ring I cut, I just had a pencil mark and I was trying to follow it. If you've ever used a scroll saw, you know that the sawdust loves to accumulate right before the blade. I don't know why. It won't go anywhere else, but right before the blade, it'll accumulate and make a nice little pile. You can't see where you're going, right? So you have to go, and you get tired of that, or you brush it off. So what I did after I cut the first ring is I put it back on the lathe. And remember, I had my 1/8-inch holes already drilled. So I put it back on the lathe, and I took my thin parting tool, and right at the middle of that hole, I went in at approximately a 45-degree angle, about a 1/16 of an inch deep. So now I've got a nice little groove I can easily follow. So you cut all these out. Let me just stack them together real quick like, and then I'll tell you about how I did it. Is that right? No. Turn it this way. I made a couple of these a while back, and
Got it on camera if you wanna leave it there, because I have the.
oh, okay. So anyway, there it is, and once you get these rings cut out, you just simply glue them together, and having the lines there, you just match them up. Try to get them as matched up as good as possible. And that's it. You just simply turn it. This is one way to do it. Another way of doing it, okay, this is 12 by 12. Another way of doing it is you glue up a 6 by 12. Or two 6 by 12s, sorry. And then you scribe your circles. You go to your bandsaw, you tilt your table at a 45-degree angle, and then using like maybe a 1/4 inch or 3/8 inch wide blade, you cut semicircles. And you do that for each of the two. The only problem with that is that you got to join them together. And did I mention it can be tedious? And you see, when you're trying to maintain the lines so that it looks like this was cut from a solid piece, whenever you do any grinding or adjustments, you're going to lose the accuracy there. So that's the second way of doing it. There is a third way of doing it, and this company makes this machine called a ringmaster, right? And you can get a freestanding ringmaster that's motorized, or you can get the attachment. And I think they have an attachment for a small lathe and one for a big lathe, right?
Let's see what size they can do. They can adapt it to.
Well, anyway, my good friend Roger brought these up today, and he did these with his ringmaster. Look at that. That's beautiful. This is just pine? Yeah. Pine. Yeah. Look at that. It's beautiful. And of course, this is his favorite. Lots of little pieces, right? What segment is that? 16?
20.
20 segments.
Plus the space.
Plus the spacers, yeah. So that's 40 per ring, right? 1, 2, 3, 4, 5, 6, 7 rings. 280. Now, the only thing about the ringmaster is you've got to have a 1/2 inch hole right in the middle. But there are lots of ways you can get around that. You know, you can plug it or do whatever. And then this one right here, this is another, I mean, who would have thought pine? You know, you don't have to have Bacardi to do beautiful work.
That's 12.
Okay, 12 segments. Now, also, the nice thing about the Ringmaster is that you don't have to stick with 45-degree angle. You've got you can vary it, right? You can do different angles. Whereas my little thing is 45. Now, so how did I do this? You're probably wanting to know. Okay, it's 12-inch diameter, so the radius, 6 inches, right? I wanted to have a large enough base that it's going to sit on. So I came out 1 9/16, and I made a mark, and then I incremented by 7/8 of an inch.
When you say 1 9/16, and you're looking at the figure 1.5.
That's the decimal.
9/16.
That's the decimal, yeah.
Didn't you go to school that
Wasn't that critical surgery, was it?
We didn't do anything with the 9/16.
And that all you do is increment up 7/8 of an inch and drill a hole at a 45-degree angle. I drilled it with my hand drill, my DeWalt. The only thing you have to do is be careful that you try to keep it straight, because remember, you're feeding that little blade on your scroll saw if you use that. And if it's real crooked, then it's going to be difficult to go in there. So you just drill the little holes, feed your blade in there, cut it, glue them together, and that's it. That's all there is to it. All right.
Then what happens when you don't, you do a 45, you do a different angle?
I don't know.
Well, doesn't that angle depend on the thickness of your wood with Ringmaster?
Well, yes.
The angle depends on the thickness of the wood.
That's right, yeah.
And usually we wind up with, I usually don't have 3/4 when I get mine glued up and planes out.
Yeah, see, if this was, say, 1/2 inch or something like that, then from this point here, you're going straight up. This is going to be your overlap, you see. So if it was thicker, then you could probably change that angle and still be able to get an overlap. I don't know, but the Ringmaster's got this long chart, right? It gives you all the information. You choose, okay, this is my thickness, and I think 1 inch is maximum, right?
Yeah, you do have to know how to measure and how to average figures. But other than that, it's not that.
Piece of cake. Yeah.
You have to know what the angle of the tangent is.
Oh, yeah, okay. There we go. The angle of the tangent. All right. So that's all there is to that one. Now I've got one more that we'll talk about, and then that'll be it for me.
It'll take you about 10 or 15 minutes to put this thing together.
Oh,
Scroll saw for sale if anybody's interested in it.
there you go. Okay. Now, this little guy right here, I have seen various open segment pieces done, and you did one, right?
Yeah, I was gonna say, I think you could.
Yeah, and he has this interesting little fixture that he made. It clamps on your lathe for your indexing and gluing it. I went to a company called Seg Easy, and I've got a sheet that I'm going to pass out. It's got all these information. They sell these plates, plastic, and this one has 24. Yeah, 24 segments, and the angle is, I think, a 5.5-degree angle. So what I did, since I'm a pro at making sleds, I made myself a Seg-Easy sled with a 5.5 degree angle. And I only had to make 2 adjustments to get it right. But all you do is, let's see where they are. Yeah. Is cut your little segments on your table saw, and they look like this. And then you just slide them in these slots. Let me do it like that. Slide them in these slots, like that. Put them in there. Get a little paintbrush and paint your glue on, and then just glue your ring in. Now, if you want the segments to go closer to the center, what do you have to do? You have to make it a little bit smaller, right? And so the fatter it is, the further out it'll come. The first time I did this, I thought, man, this is so easy. I put all my things in there. I glued my base on, and I tried to take it off. Did I mention it can be tedious? Anyway, I finally pulled it off, but I left 2 or 3 still in there. So I thought, okay, that's plan A. Plan B comes up now. So then I cleaned it all up and I re-glued everything. And then, but before I got ready to pull it off, I put a hose clamp around everything and I tightened it down a little bit, not a lot, just a little bit. Then I had the challenge of getting it out. Have you ever tried to open a paint can that's been sealed for a year? You can't just go, right, and it opens. You have to go all the way around. Well, that's what I did. I pried a little here, pried a little there, I go all the way around. About second time around, it started moving. Well, once it starts moving, then it just comes right out.
You kind of made it harder when you put the band clamp on because it pushed the segment.
Didn't I tell you there are a few mistakes I've missed? But actually, the band clamp, yeah, if you give it if you give it too much pressure, then you're going to lock it in there. Yeah. But by giving it just enough pressure, as you pry on this one right here, the others are going to be somewhat connected. Yeah. You see, so it's going to help in popping them out.
What about the stuff that you was talking about earlier? You used resin and stuff to keep it from sticking. Could you use that on that?
Oh, a release agent.
Or some motor oil.
Jim, is it just because it's wedged in there?
It's not glued. It's not the glue.
That's right, yeah. You see, now this one right here, the base is what, 4 inches in diameter or something like that. So these were my first pieces right here, this ring right here. Those were my first ones. And you see, you can probably see that the taper here is, it's smaller than this one up here, and smaller than, well, anyway, you can see that. So that was my first ring. After I glued it in, what I was going to do is the second ring I was going to glue so that it split the first ones. And I thought, goodness gracious, how am I going to do that? So I didn't know how to do that. So that's why I came up with the ring, because I had to tie it together somehow, because I didn't know how to go from here up to there with one solid piece. Maybe you can show me. So anyway, I put in the first ring of sapele. I think it's, 1/4 inch. And then glued some more segmented pieces, open segments, and just went back to the same fixture, just glued them in there. Use a paintbrush, because if you put too much glue in there, then you got to deal with all that excess glue once it dries. So you want to just paint in just enough like baby bear's porridge, you know, just right. And it's just a case of building it up, and then turning it was fairly easy. You don't have too much problem with tear out or anything like that. This is maple and walnut. And I think the base and the rim is Paduke. So anyway, you should try doing some segmented pieces. You don't have to do anything big, anything huge. Here we go. You can do something small, like this. This is Australian Jarrah and spalted pecan. And also the lid. So, you know, it doesn't have to be something big, but start up with it. And once you get familiar with the segmented principles, you can incorporate it with lots of other designs. You know, like for example, this is one of my favorite pieces right here. This is a nice piece of sapele, but sapele by itself is kind of bland, I think. So by adding just a couple of rings, it really dresses it up. It makes it bigger, and it didn't take a whole lot of material.